It's recording now.
Cool.
What's the link for participants? I was just gonna send it to the TSC chat.
For the Zoom call?
Yeah.
I don't even know where it is. Oh.
It's on the Facebook page.
Can somebody send it on the chat?
I think I have it copied still. Should be the right one.
Thank you.
Oh, yeah.
So let's wait for, I don't know, 18 participants or 3:05. Does that sound like a good starting time for you guys? If everyone comes first.
Yeah, we can wait.
Yep. Billy Joel.
Oh, I wasn't on mute. I thought I was on mute.
You guessed it right.
That's a song
Thanks,
that
Thomas.
I think it was.
Yeah, it's Billy Joel. Longest
Nice.
time.
Billy
Right.
Joel. Nice.
It is nice, yeah.
Daniel Pack. What's up?
All right, that's 18 participants. So
Is it
I
really?
guess we'll go ahead and get started.
Oh, cool.
So welcome everybody to Programming in the Cloud. This is just a workshop designed for an introduction to Python from the basics up. And so we have the tiny URLs there, and they should be posted in chat. So one to the slides and one to Google Colab, and we'll go over what that is in a minute, but that's where we're going to be running all the programming. Just a little bit about us. My name's Chase. I am a technical chair with IEEE. And IEEE at UCSD, we're a nonprofit, pre-professional student organization dedicated to provide engineering students with resources to help them achieve their true potential as they develop into professional engineers.
Okay, and my name is Anushka. I'm currently a developer and transitioning into VP Internal with Triton Software Engineering. And we are an organization of engineers, designers, and problem solvers offering pro bono technical and web development services for nonprofits.
So as I said, Chase, hello.
Will is somewhere.
Hello, I'm William. Oh, it's off. Whatever.
I am Tim. I'm one of the other technical chairs.
Yeah, my name is Vrin. I am also a developer and transitioning into the VP external role.
So a quick history of Python that is going to be more relevant to what we're doing today. So Python was developed in 1996 by Guido van Rossum, and he had been the benevolent dictator for life of Python until he stepped down in 2018. There's three major iterations of Python, you could say, Python 1, 2, and 3. Yeah, pretty much everyone does Python 3 nowadays, so that's mostly what we're going to be focusing on. And our workshop today is going to be using a version of Python 3.6.
So a little bit about why Python is a really popular language these days, and a little bit of its basis as well. So Python was basically founded on the idea that the code should look nice and be simple. And that's the basis of why it's a spacing-based language. So it looks nice because you're forced to look that way so it can't compile. And then it's an emphasis on like basically spoken word when we use it. So for example, in other languages, when you're doing like an and of something, if you're familiar with the concept, it's using two ampersands, whereas in Python, it is just the word and. So it's supposed to look nice and be easy to understand. And that's the whole reason it was created. And that the reason that it's supposed to look nice and be easy to understand is because in the programming world, you're going to be working with other programmers in the future on like teams and stuff. So you want your programs to be understandable by your team members. So it's more important that your program is easy to read than it is that it like executes as efficiently. So that's the idea behind Python. And just a little bit about why Python and some advantages and disadvantages. So that readability and simpleness, it lends itself to being a really easy to learn language. Because of that simplicity syntax, it's all based on spacing, which is really intuitive. And from that ease to learn, it's also really accessible and allows for you to make really fast prototypes. Like I know, for example, for me, when I do hackathons, I usually start with Python as the language, just because it can do pretty much everything you need, and it's really accessible in that way. And there's just so many libraries and things that have been created for Python because it's so used in so many different fields that you can do just about everything you want with it while being approachable. But as far as disadvantages go, Python is a higher level language than a lot of other languages, which means it takes longer for the compiler, in this case actually an interpreter, to translate your code to something that works. So its runtimes are generally slower than really low level languages. One disadvantage could be the spacing and indentation. It's supposed to be easy to read, but it also can be easy to get caught up in like why something isn't spaced right or something like that. And then it is a relatively simple and approachable language. Lots of libraries do help with its applications, but in its nature, it's pretty simple and can be limited by that. So just a couple things that we're going to be covering today. The emphasis of this workshop is knowing very little programming in general and the very basics of Python as well. So we're going to be going over just really basic data types, so numbers, strings, and all the other variables you can use in Python, as well as a bit of input-output, so you can print out stuff so you can see and also get input from users. And then we're going to go over some loops and like conditional stuff like if-else statements and a bit of Boolean logic behind that. And then finally, we'll be going over functions, the parameters for functions, and then how returning works in Python as well. And so all of that, we're going to be starting from the ground up, but the emphasis is going to be on learning towards the end goal of making a hangman game. And we will be using just about everything we're going to be learning today in making this hangman game.
Okay, so what we're going to be using is the Google Colab. It's like Python Notebook, but essentially we can work with Python without ever having to download anything. It's online. So if you guys click on the link and open it up, towards the top, there should be a button that says, I think it's run in playground mode. Basically, this way you guys can edit it without having to actually change any of our stuff locally. And we have a quote from Obama, don't just buy a new video game, make one. Don't just download the latest app, help design it. So we're making our own hangman instead of looking it up online. And so first thing we will cover is variables. One really important part about Python would be how it runs with variables. We have dynamic typing as opposed to most languages. So this means that variables and data structures that we use do not need to be declared. So if you guys have ever tried learning another language or have like started another language, you might remember something like int x equals something, or string this, or you have to define everything. But in Python, that's not necessarily necessary to declare at the beginning, and also it does not need to remain the same type. So if you look at the code block, and by the way, if you guys are in the playground mode, you can edit the code blocks and change whatever you want, and you can still run it. So we look at number, we just write number equals 11. We don't ever have to declare it as int number. And if we want, we can change it numbers the string 11 at the same time. And Anushka, if you run the code block, you should see that it runs. You should see that it's still valid regardless of what type the original variable is. You can change it to whatever you want, and it's always valid. And so in Python, there's 4 major numeric types. There's integers. So if you look in code about x equals 5, it's just like in math. It's any whole number, any non-fraction number. It can be positive, negative. Second type is floats, which is short for a floating point number. But it's really just any decimal number that you want because the decimal point floats. It can go anywhere. And the third type is called a long, and it's just a really long number. But fundamentally, there's no difference between float or long. You can use either in any case, especially since you don't need to define it. You can change whenever you want. And the fourth type is a complex number. And the most important part to know about it is that there's a real and imaginary part, but instead of I, like you're used to in math, Python uses a j instead for the imaginary part.
Okay, so if you guys are in playground mode, these are some examples that you could try around in like by editing the code. And so essentially we have like basic examples, and then this example is to show you that you can have really long numbers and do like larger calculations. So if you guys want to test these out, like we'll give you like, I don't know, like 30 seconds to. And just like make sure you're able to edit the code in Playground. Okay, and while you're doing that, I'm gonna keep going. So basically, as Tim covered, these are the numeric types in Python. So we have integers, and basically integers are just regular whole numbers that are not fractions. And you can have signed integers as well. So basically, you can declare negative numbers. And then we also have floats and longs, which are decimal point numbers. And if you're using a long, for example, you can put an L at the end of the number to designate it as a long. And basically you can use floats and longs to like also represent octal and hexadecimal numbers. And then we have complex numbers, which have the real and imaginary part, and they're written with this syntax with a J instead of an I. So next we're gonna cover strings.
All right, so for strings, in Python, it's just when you, or in any language, it's just for you surround a word and you with either single quotes or double quotes. And in Python, it doesn't really matter which one you use as long as you're consistent and you start and end with the same. And it can even be more than you could do a string with triple quotes if you want. It's just as long as you, however many you start with, you have to end with the same amount. And then in Python, there's no need for space allocating. So any string you want, it can be as large and small as you want. The program will automatically adjust for it. Unlike other languages where you might have to declare a string or like an array of letters and have to have a set size of say like 5 characters. And then another important part for strings in Python or in any language is concatenation, which is just a fancy word for combining. So example, we have the string cat, and we have the string dog, and you combine it, it'll be cat dog. And similarly in the code block, if we run it, we have the underscore and we concatenate it, we add it to hello, and then we add it to another underscore. So now it just prints hello. Or what you can do any combination as long as you want. You just have to add the plus sign in between. And one final note is like lists and strings, we have certain syntax, and we have something called slicing. Is basically if you want to get a portion of a string, let's say the first 5 characters. So you're like slicing the first part of it, either the first part of the string or the first part of an array, which we will cover after.
So as Tim said, we can either use double quotes or single quotes interchangeably, and they would give you the same result as long as you're like consistent. And so you guys can edit the code block to find a way to print sky if with the syntax. And basically, like the first line would print hello world. This is the same string concatenation, and then these are the two ways to do it. And I'm going to keep going while you do that. So, okay, so to convert between strings and numbers, we use a process called casting. And so basically, if you have a number and you use the string function, you can convert the number to a string. And same vice versa, if you use this syntax, then you can convert a string to a number. And then, so string slicing is basically, so strings are a list or a list of characters. And so you can index from 0 through 4. So each character has an index, and Python is zero-based indexing. So you start at 0 and it would be 1, 2, 3, 4. Another thing with Python is you can go the other way. And so the last letter would is -1, and then you go all the way up to the magnitude of the length of your list with a negative sign. So basically, since this has 5 letters, you go up to -5. And so you guys can think about what the output of printing name 0 and name -1 would be to index. And then you can, there's also several functions with strings. So the len function will return the length of the string. The type will return what type of variable the a is. A.split uses a delimiter, so like spaces in this case, and it'll separate the string into a list with each of the words. And then this syntax will reverse your list. And then, reverse your string, my bad. And then you can also use variables with strings as we covered before. So if you have, if you designate first name and last name in this way, then you can use string concatenation to print it out. And then we can use strings slicing. So basically, if we go from 0 to 5, you're going to print out characters 0, 1, 2, 3, and 4, and you're not going to print out the 5th character. And then you can access a character in the string in this way. So you guys can try playing around with this syntax and find a way to print sky with a variable, and also practice with string slicing in the Google Playground, and we'll give you like 30 seconds. Okay, and you can also use the string casting function to be able to print out ints. So basically here we have a row variable and a call variable, and you can use string concatenation with this functions within the print statement to print out my move is 1, 2. And so you guys can try printing out this in Playground.
Oh, one thing to note is that concatenation only works with strings, which is why she had to first typecast and change rows, which is originally an integer, into a string.
And then, so this is the syntax for commenting in Python. So if you have single line comments, you use the pound or hash sign. And so anything after that sign will be ignored by Python. So you can comment out code that you don't want to be print, and you can also use comments for like providing, like if you come back to it later, to be able to tell like what you were trying to do with your code. And then using 3 pairs of quotation marks works for multi-line comments. So basically everything in between these 2 pairs of quotation marks will be commented out. So if you want to comment like a whole chunk of code out, you can do it in this way. And then now we're going to go over Boolean and logical operators. So.
All right, so Boolean is a huge part of any language because it's used for control. So in most languages, there's true or 1, just indicating like true. But in Python, you can only use true, I'm pretty sure. And then on the opposite, we have false or 0. and then in Python use false, and then not, or a lot of times you'll see an exclamation mark in front of a Boolean operator to say like the opposite. When Python use not. So if you look in the code block, we have door open equals true, and you have to make sure true or false are capitalized, and however not is not capitalized. So if let's say you want to say door open equals false, you can either write false, or in this case we put not true, which is equivalent to false.
Okay, so basically your Boolean and logical operators, as Tim said, are true, false, and then we also have and, or, and not. So if we have these statements, so true is true would evaluate to true, true is not false would evaluate to true. And basically what and does is if you have two like this first statement and the second statement, if both the statements are true, then this statement will evaluate to true. But if either of them or both of them are false, then the statement will evaluate to false. So since you have one true and one the other one being false, you evaluate to false. Or just requires one of the two to be true. So either if one is true or both are true, the statement would evaluate to true. And if both are false, then the statement would evaluate to false. So as you can see, this evaluates to true. So this is some practice for you. So assume A equals true, B equals false, and C equals true. Play around with the code and see like what this would evaluate, or also you can think about it logically. And if you have B as false and C as true, then this statement would evaluate as true because at least one of them is true, and then A is true, and this statement is true, so the entire statement evaluates to true. Similarly, you can try this out, and then we'll go over the ifs. Okay, so if you have a conditional in this way, then if you have is true equal to true, this will evaluate to true, and the conditional would execute. And if you have just B, it's if false, so the conditional would not execute. So now we're gonna move on to.
And the other part of Boolean that matters is conditionals, which is when we want to, let's say we want to execute a code only if sometimes depending on our condition of something else, which in this case would be, we have a variable again, door open equals true. So we have an if statement, and if door open equals true, then anything after that in that little, we'll space it over. Anything within its section will be, the command will be run. And similarly, we don't have to also write door equals true. We could just write if door open, which is equivalent to if true, the code should run. And moving on to that, an example of the not operators, we could have the door opens false, and we write if not door open equals true, which is equivalent to if not false equals true, which is if true equals true, then it will print. In this case, the door is closed. And so then we have what is known as if statement, which is if, elif, and else, which essentially the if will check the conditions. If that statement is true, it will run command accordingly. If that doesn't happen, it checks the elif, which is like another option of if statement that runs second, checks those conditions. If those are true, then it will run any code accordingly. And finally, if none of the if statements, oh, and you can have unlimited elif statements. You could have if and like 6 elifs if you want, which might not be efficient, but it works. And if none of those statements are true and happen, then finally it goes to the else, which is like the default command, which will run. So in this case, we have using our conditionals with our Boolean, we have if door open equals true and it is winter equals true. So in this case, both of those have to be true for it to run the code, for it to print it's cold out. And let's say that's not true, then it runs a secondary. If doors open is true and in winter is false, then it will say the nice breeze is in. However, in this case, none of those, in both cases, none of them are both true. So it goes to the default statement, which is the door is closed.
The slides are, I think, going to go over if and else examples after, so I think you can go ahead and explain lists.
Okay. And for lists, sorry if this is a bit out of order, but lists were just like strings before, where in this case, it's a group of elements, and in Python, we use brackets to enclose it. And this is the same thing as an array in another language. And once again, in Python, the size does not matter. You can, in real time, you can change the size however you want. You can add or remove elements in any time. Whereas in most languages, you have to declare beforehand the maximum size. Let's say you have a list that has 5 elements and you can only have 5. Whereas in Python, you can add as many as you want. And like we saw before, we use the bracket element to pick and choose which element we want. Let's say we want the first element. Since Python is 0 index based, we write in my list in bracket 0, and that returns the first element. And the second example in the code block would be the list slicing, which is the same as string slicing, where it goes from element 1, 2, and it doesn't do 3 because it doesn't take the second part of the slicing. So in this case, it should return 2 and 3 if we run the code. Yeah, and finally, we're using another one of those built-in functions, the length of. It just returns the length of the function that is our parameter.
Okay. So basically the slide says the same thing. So you would have a list with brackets and you would use commas to separate it. And again, it's 0-based indexing in Python. So the first element would be 0, 1, and then 2. So here are some more example lists. So you can have an empty list. You can have a list of numbers. Again, in Python, like your type doesn't matter. You could have whatever type you want it to have. So if to access an element, you're going to use 0-based indexing. So this num list 0 would access the element 1. And then you can update the elements of a list. So you could have num list 0 on the left side of the assignment operator and assign it to 10. So this would change this list to be 10, 2, and 3. So here are some more built-in functions that you can use with lists. So let's say you have the list A with C, Java, and Python. You can .append to the list, so that basically adds an element to the end of the list. You can insert it at a specific location, so this would add the element to the first index, so it just shifts the rest of the elements over. You can delete a specific element, so if I'm deleting -1, again, Python goes forward and backward. So if you're deleting -1, you're going to delete the last element of the list. So you're going to be left with C and Java. You can pop, which basically does the same thing. It pops the end of the list. So you would get rid of the last element. You can return the count of the list, and you can ask Python to sort your list for you. So here it's sorting in alphabetical order. And sorry, just to be clear, each of these functions don't depend on the previous one. We're just pretending like each one is happening separately to the list here. And then we can have nested lists in Python. So basically you can have lists within lists. And so here, if you tried to get the 0th element, you would get this entire list. So this is the 0th element, first element, and second element. And if you wanted to access a specific element, you set 2 brackets. So basically the first bracket is which list you're looking at. So 0, 1, so you're looking at this list. And then which element of that list you're looking at. Oh, sorry, this is incorrect. This should be B over here, not A. Because this is the first element because it's 0-based indexing. And then here's some list practice. So if you want to test this out and see what happens when you have a nested list within a list in Playground. And we'll give you like 45 seconds to do it.
Yeah, and if anybody has any questions, don't be afraid to ask them in the chat or in person.
I'm not sure if we're giving you guys enough time to like test this out. But, oh, there are questions. Okay.
Do you just answer or do you just type it?
You can just answer.
Okay. Can you not have not on one side if statement? Yeah, not is not like, it's not, you don't necessarily need it. Like for an if statement, you could have as many. Also, yeah, one thing for if statements, you can have as many conditions as you want. You could have if condition 1 or condition 2 or condition 3 or condition 4 or condition 5. You can have as long as you want. And for any of these conditions, you can add not to whichever one you want. It's just kind of like a inverting.
Okay, cool. I think we can keep going. So there's tuples next. Do you guys have this? All right, I don't think they talk about tuples, so I guess Chase.
Thought I put a section in for tuples, but a tuple is, it's very, very similar to lists. So where lists were enclosed by square brackets when you're creating them, tuples are just enclosed by parentheses instead. And you can do the same kind of indexing rules that we've been going over with lists and strings with tuples. Just one thing that is different between tuples and lists is tuples are read-only. So that means, whereas lists, like we could have changed elements, like we could have changed the first element to change it after we created the list. In tuples, when you create the tuple, the elements are like read-only. You can't change them at all. So you can access them, but you cannot change them. So there's some example code just here in the slide that if you guys want to go ahead and play around in the playground and see what happens when you try to access versus change. So just go ahead and take, I don't know, a couple of minutes to do that.
Oh, and an example of when you'd want to use a tuple as opposed to a list could be things like days of the week or months in a year, something you know will never change. So if you just want like a list of all the months, you might make it a tuple this way. You're sure no one ever changes it on accident. So hopefully you guys had a chance to play around with tuples a little bit. And if you did, you'd see the second statement there where we tried to change a tuple, where we tried to index and change it, my tuple 0 to my tuple 1. When I put that into my playground, it gave me the error, tuple does not support item assignment. And so that just demonstrates that tuples are unchangeable, but you still can access them like when we printed in the first state. So the next thing we're going to be covering is conditionals. We went a little bit, we saw them a bit when we're working with Booleans because these conditionals work really closely with the Boolean stuff we were going over. And there should be a little bit of how conditionals work in the code here. Or actually, wait, Tim, did you already go over? I think you already went over it. Yeah, I think we covered a bit, but
I'll go over it just briefly because we went out of order and just to give you guys a refresher. So our conditionals, it's really just the if, else if, or I guess in Python it's elif, but it means else if, and else conditionals. So the syntax is very similar, so the syntax is if, and then you can optionally include like brackets around your if to make sure like what condition you're checking, or you can just have one expression evaluate. So in this case, we have if hours less than 12. So the conditional would be is hour less than 12. So we have hour up above is 14. And so if that conditional of hour being less than 12 evaluates to true, then the if block will execute what's in its indentation. So in this case, the indent under the if, the singular tab, would just be printing good morning. Whereas if it's not true, if you set up an else block after an if, it will execute if the condition for the if was not true. So in that sense, if your if conditional is true, it will execute if, and it will stop looking past anything else. And if it's not true, it will keep looking for the next true condition. And so that leads right into elif. So it's in like English, you would say if, otherwise else if, do this thing, and so on. In Python, the syntax for that else if is just elif, the single word. And it's very similar to the same if thing. If its conditional is true, it'll execute its code of block or block of code. And if it's false, it will just move on to the next conditional until it finds one that's true, or if it doesn't find anything, it just won't do anything. And Tim went over it a bit, but you can add as many elifs as you want. Just keep in mind that the first one that the code, when it's running sequentially down the list, the first one that's true will execute, and then it won't look after that. It'll just exit out of the like sequence of else's and ifs. And so these are used when you want to execute code based on conditions. So in this case, we're deciding whether we want to print good morning, good afternoon, or good night. In Hangman, we're going to use this extensively to be like, oh, if our letter was correct, we want to do something, whereas if our guess wasn't, we're going to do something else. So yeah, anytime you need to check like conditions to see if you want to execute code, you're going to be using if, else if, or else, and like as many of them as you need or want. And if you guys want to go ahead and just take like a minute and try out the syntax for if, you can try like multiple conditions in your if, multiple conditions in your else if. One thing to note though is the else block does not have conditions. If you want an else with conditions, you'd have to use the elif block. That's basically what it is. Whereas else is, it'll just execute if nothing else was true. So go ahead and take a minute or two, I don't know, make a fun little text-based game or whatever you want, maybe try out the examples and just see how it works.
Also, do you guys have any questions up to this point on anything we've covered so far?
All right, so Doug, in response to your question, in Python, we generally don't really use brackets. So instead, everything's just based on the indentation. And that's part of why a lot of people like Python is because that style kind of forces clean readability. And so you just check, well, here's my if statement. What's the next indentation block? Everything in there that is within my if statement. And then once you exit that indentation block, then you know that you moved out of the code that's within encapsulated within that if statement. Does anyone have any other questions? So I guess we'll continue. If you feel like we're going too fast, just let us know. Yeah, so oftentimes we wish to execute certain lines of code multiple times. For instance, in machine learning, we want to do something over and over again, maybe hundreds of thousands of times. We don't want to manually write out this code 100,000 times. So instead we use a for loop, which basically tells us to repeat a section of code a specified number of times. So in Python, we specify a for loop just with the keyword for. The difference, however, compared to many other programs is that typically in Python, we can only iterate over sequences. Generally, we can create sequences using, for example, the keyword range, which creates a sequence of numbers. And then we specify what we're going to name every single value inside that sequence as we're going through our for loop. For instance, in the first example, we say for val in range 110. That means we're getting a sequence of the numbers 1 through 10 minus 1 because of how range works. And then for every single one of those, we're going to call that value val. So val will begin with the value 1. The next time we do go in, through our for loop, it's 2, and so on. Now, a feature of range is that simply because for ease of speed, since many people just want to begin from 0, you can just leave out the first number if you want to start from 0, and then it will assume that the starting value is 0. Another way to go through sequences is to simply take, say, a list or a string, and then we can just specify, all right, I want every single character or every single letter or every single element inside my string or list. And then, so in this case, we're going to say for letter in Python, which is the same, we're going to go through each letter of Python, and now we're going to do something with it. And so in this code, you'll also notice that we have 2 lines of code in it. So for every single letter, we're going to first make that letter capitalized, and then we're also then going to print out that letter. Now, as we had observed previously, using range, we could get a sequence of numbers. And sometimes, for example, we have a list, and we want to go through every single index of the list, perhaps to access the element. Or perhaps we're also using the index in a certain manner that the index is actually relevant beyond just the value. Using the fact that we know how range works and how we can use length in order to access the length of in order to get the length of our list, you can use a for loop through the sequence created with range len my list to get a list of len numbers, or of len of my list numbers from 0 to len my list minus 1, which it corresponds to the index numbers in my list. And as we had seen before, kind of like how we had gone through every letter directly in our string Python, we can also directly loop over our elements in a list. So in this case, we're just doing for value in my list, which will give us 1, 2, 3, 4, and 5.
So this is just the basic syntax we were going over for the for loop. So that iterating variable is the one you get to name, and it's basically created right there. And it takes on the value of each value in the sequence that you give to the for loop. And that's kind of the whole use of it. So oftentimes you'll use for loops with ranges like we showed, just to do a certain thing a certain number of times, whereas other things you can do is perform operations on each element in your sequence, like we went over before as well. So go ahead and try out these what these for loops will print in your playground, and if any of it's different, maybe bring back some questions on why. So hopefully you guys had a chance to check out what each for loop would print out in Playground. For me, I got, when I typed in the for num in range of just 3, it printed out 0, 1, 2. And that's because, remember, if you don't include that first index on range, it starts at 0, and it doesn't include the last number. So it goes from 0 up to 2, but not 3. And then range 1, 5, I got 1 to 4 for mine. So yeah, that just demonstrates that you can repeat the code multiple times. So instead of printing out the value, we could have performed a function that we're gonna learn about functions later in this lecture, lesson, workshop. I don't know exactly what to call this. And so you might want to do something that you created multiple times in your for loop. And then the last common use for for loops is like taking the value of each thing in a sequence. So in this case, we have a list of 3 things and we're iterating through that list. So what do you guys think it's going to print out? Or you can also go ahead and test it in your work or your collab as well.
So moving on, while for loops are extremely powerful, sometimes we don't know when exactly we want to stop doing something over and over again. For example, perhaps we're prompting a user for input and we want to keep on asking them for input until they put in input that is accepted by our program. In this case, it's better to use a while loop, which basically repeats a loop until some certain condition, which can possibly change as we're going through a while loop, becomes met. So in this first while loop, we're kind of using a while loop as a substitution for a for loop. So we're beginning with a value I and 0. And we're just going to say, as long as I is less than the length of my list, I'm just going to add in the value of that list. And then we're going to move I up 1. So we're basically using I to access each index of our list, and then adding the value at that index to our sum. And then once I reaches the end of our list, we're going to our condition in our while loop evaluates to false, and then we exit our while loop. With while loops, however, sometimes you may have a condition that always evaluates to true. For example, if you say while true, then in theory, your while loop will be running infinitely because true is simply true, right? In these cases, we can use the keyword break somewhere in our while loop. And when you call break, it basically tells the program to exit outside of your while loop. So in our sample program here, it is a similar program in which it will print out the sum of all our values in our list. Only instead of using while I is less than length of my list, we're kind of going to do the opposite of that. I'm going to say, well, that is false when I is greater than or equal to the length of my list. So in this case, we're just going to check, is it greater than or equal to the length of my list? In that case, then we say, all right, we've gone through our entire list. Let's exit our while loop.
So yeah, just like Will was saying, the while loop, very similar to the if, that it takes in that condition. In this case, the while loop will repeatedly execute its code until that condition is false. And it checks it after executing all of the code. And so the examples we went over, and the next example is, this is very similar to something you could do with the for loop. The for loop and the while loop have a lot of the same uses. You can use both interchangeably for a lot of different things. But they do have some distinct things that change, like Will said, you might want to do something forever, like that while true we were using, whereas you can't do that with a for loop. But go ahead and take a minute and just think about what, oops, I hopefully didn't just change the slide, actually, because I just did on my tablet. Think about what this should output and then test it and see if you guys got the right answer.
I believe the recording will be uploaded to YouTube at some point. I don't know the specifics of when that will be and where exactly. So I hope you all had enough time to test out while loops and how they work. So now we'll be moving on to functions. And so similar to how with for loops and while loops, we didn't want to write the same code over and over again. Functions are kind of similar in that oftentimes there are cases where we want to perform the same thing many times, and we don't want to write out that entire thing every single time we want to use it. So instead, we'll put that code within a function. And then in order to do all that code, we'll just refer to the function to do that code for us instead of having to write it out all over again. An added benefit of doing this is that suppose we want to make a slight change to how we're doing whatever code we want to execute many times. When we put it all within a function, all we need to do is edit the code within our function in a single place. And then that change will propagate to everywhere where we wanted to have that change done because they're simply referring to the function. Functions also help make it very clear what exactly we want to do in the code. So typically in Python, we define a function using def and then our function name followed by parentheses and then a colon. So that this allows us to call our function name by simply saying function name parentheses. Now many functions can take in parameters and return values. Parameters are values we pass into our function from wherever we called it. And when we pass it in, we give it a name, and then from there we can then refer to that parameter using that name inside our function. We specify the parameters inside a comma separated list between the parentheses of our function. So for instance, when we are using len of my list, we're calling the function len, which takes in some variable, in this case a list, and then it takes that list and then counts how many elements are in there, and then gives us that value. It gives us this value through a return value, which basically is some value that the function will output after running all the code. Now, this value is typically something that is obtained through the code inside our function.
So again, this is just the basic syntax of declaring a function. So we do the keyword def before. I keep moving things on the slide on my computer. And then, so you make your function name whatever you want to call it. One of the handy things that William was going over is if you name your function what it's actually doing, it becomes a lot easier to read your code. So in this case, the example of def function name doesn't tell us anything. It would be a bad function name. But then after the function name that you choose, you can, in the definition of your function, decide how many inputs your function wants to take. And you can have as many as you want. They just have to be separated by commas. So in this case, this would have two arguments, arg1 and arg2. And then inside the function is where you define what your function is doing. It could be anything you want. And you can optionally return something from your functions. So in the case of our second function, we're going over here, the add two nums. It makes sense for our function to return the number that we're adding, right? Whereas some functions, maybe you're doing something that like prints out what your guess in your hangman game is going to be. It doesn't really make sense to return a function because the whole point of the function is it's doing the operation of printing itself. So you don't really need to have anything returned. So you can return things, and you can return anything, any kind of variable Python supports, but you do not have to. And so like Will went over, calling functions, once you define the function and what it does, to later call it, you just say the function name and then make sure to do the double parentheses and however many inputs the definition of the function was given. So in the case of our add two nums, we had two number inputs. So when we call the function, we need to make sure to provide it with two numbers. And then one thing that might come up useful when you're making functions is the idea of default arguments. So in the definition of your function, when you specify how many inputs there are, so in the last case we had num1, num2, instead if we changed it to num1 and it said num2 equal to some value in our definition, this is specifying the default value for number 2. So that means when we call the function later, if we specify it in this way, it still expects 2 inputs, and it'll assign it normally as you expect if you pass it in 2 inputs. But if you don't pass in the second input, like you forget it and say you're trying to do print of add 2 nums and you just pass in 1 value, the compiler will default the value to what we specified in the definition if you don't provide it. So in this case, adding 2 nums, since we only provided 1 input, the compiler will look at the default value, which we defined was num2 equal to 30, and use that value. So if you guys want to go ahead and make your own function, like the example we just had of add 2 nums, and test those 2 lines and see if they output what you expect. That way you get a little familiar with creating them as well.
And one case we could see the use of default arguments was when we're using range and for loops. Remember that when we only included 1 argument, the start was automatically set to 0. So somewhere in the range function, wherever Python defines it, the definition for range likely says something like start equals 0 at the start to say, well, if somebody doesn't specify it, we're just going to set that value to 0.
Oh, and one final note about functions as a whole is because of Python's dynamic typing, in other languages, you might have to, when you like declare a function, you have to might put the type like int function, or it's a void function if it doesn't return anything. And those usually matter because if you declare as a string or like an int function, you have to return an integer value, otherwise you get an error. But in Python, all you do is just write def to signify it's a function, and you can return something, or you don't have to. But Python Wheezy, this is because of dynamic, there should be no issues, and you shouldn't return any errors.
So hopefully you guys had enough time to write out that function, add 2 nums, and test that. In my workbook when I did it, so the first call we had was adding 5 and 10, and that returned 15 like we should expect. And then the second one, we called it with just 1 number. So that first 7 went into the input as number 1. And since we didn't provide a number 2, it defaulted to 30. So when I printed that number, I got 37 as my output. And the last topic before we get into creating our own hangman game is actually something we're really going to need for that game is user input. So Python provides a really nice user input built-in function, and it's just called input. And so in input, you give the argument to input is the thing you want to output to prompt your user. So in this case, when we're trying to get the value name, we obviously want a name there, right? So if we call input, the prompt is enter your name. In input, we'll assign whatever the user inputs and then presses enter. So as soon as they press enter, Python takes whatever was before that enter and assigns it to the variable name. And so obviously this is going to be really useful in our hangman game because we're going to be like, what character do you want to guess? And then that's how we're going to use it, is this user input function. So if you guys want to go ahead and take a couple seconds to test out input, see what happens maybe if you don't put a prompt into input or anything like that, because it is something we're going to be using here. All right, hopefully you guys had enough time to play around with the input function. One thing that I tested personally, because I never actually looked into it. When you do input with no input prompt, so it's just input double parentheses, it doesn't output anything, but it still expects the input. So make sure if your program like stops running randomly, you might want to check your inputs and be like, oh, I have an extra one with no prompt. But yeah, so that is pretty much the basics of Python. So we went over all the variables, all the loops we're going to need, user input and output. So that is pretty much all you're going to need to write basically any program you want. So let's go ahead and apply what we've learned today. So next we're going to be working on our Hangman game. But before we go, does anybody have any questions on any of the concepts we went over, or want us to go back and explain it again or anything? Okay, doesn't sound like it. So next we will hand over the starter code to the Hangman. And of course, if you have any questions on stuff we covered or anything like that, we will still be sticking around and likely breaking up into breakout rooms to work on this.
I think Virain was going to go over the code a little bit before we start.
Yeah, so the Hangman game starter code, we've given a lot of comments for code that we've already put in there for you that you don't need to edit. So the words tuple, you don't need to edit that. The Hangman tuple, you don't need to edit that. Any code that is already there, you don't have to change. If you could scroll down a little bit, there's two functions that you have to implement, and you have to implement the inside of the while loop inside the Hangman game itself. The first function, sorry, scroll up just a bit, is the get guess function. This one is just going to initialize an empty guess with a bunch of underscores, and the new guess function is going to be replacing that with every correct letter that is guessed. And so you build up that guess string to be matching to the secret word. Inside the run game function, if you could scroll down just a bit, there's a lot of code there. You don't have to change any of that. What we want you to implement is 3 cases for the user input. The first case is if the letter has already been guessed. The second case is if the letter isn't in the secret word. And the third case is if the letter is in the secret word. You'll need to call functions. You'll need to access an array, access a tuple. And yeah, I think that's all that you need to get started. The last part is just fill in the condition in the if statement. That's a big blank over there. That's the only code that you really have to edit that's already there. And scroll down just a little bit. If you want, if you're done with the rest of the game, create a while loop to ask for user input on whether they want to play the game again. And so you can keep running the game until the user feels like they're done playing instead of having to rerun it multiple times. So that's just the last part to implement if you're done with the rest. I think that's all that you need to get started. Yeah.
Okay, so I guess we could have you guys like tell us if you prefer working like in breakout rooms or just in the setting here and like ask us questions right here. And if you like, yeah, can you tell us in the chat if like you prefer working in breakout rooms or just right here with all of us and like ask us the questions here. If we put you in breakout rooms, we'll like try to put each of us in the breakout room and does anyone have any preferences?
Maybe we can do a poll for that.
Okay, cool. I can do that. I'm gonna group, not breakout. What do you mean by that? I'm gonna stop share really fast. Okay. Oh, no breakout rooms. Okay. I can't make a poll for some reason. I don't know what's going on. Okay, I think what we're thinking on our end is for you to be in breakout rooms initially and like talk through the logic together, and there'll be one of us in each of the rooms, and then afterwards, like depending on progress, then like maybe like somebody, like one of us can type like the code out and like you guys could follow along. So I'm just gonna make the breakout rooms right now, and I'm gonna put one of us in each room.
Sorry, we're just reviewing Zoom right now. We're kind of new to the co-hosting things.
Okay, so I have 3 breakout rooms right now with one of us in each room. So I'm just gonna open the rooms now.
Nice.
I don't, okay, this, people didn't join. I don't know what happened.
How many rooms did you make?
So first of all, was everybody able to get the code running and working a little bit?
No,
No?
I did.
All right.
You didn't even
We will
try.
go through that right now. So to those of you who were able to, great. There's a lot of things you can keep adding to the Hangman game to just improve your proficiency with Python. If you weren't able to, that's totally okay. It takes a while anyway, and we're going to cover that stuff right now. So let me just share my screen. Okay, can everyone see the Chrome video, the Chrome output?
Varian, do you see that it's recording on your screen still?
Yes.
Okay.
Great. Okay, so the first thing we're going to do is return this guess string, which is just going to be a string of underscores. So we want to create a variable with an empty string that we can just keep adding underscores to. And to do that, we want to iterate through this word and kind of go through every character in Word. And then for every character, you want to underscore to be in guess. So these 2 strings at the end of this function are going to be the same length, except this one is just going to be a string of underscores. So the way we iterate through Word is use a for loop for I in range, and the range is going to be the length of Word. And basically I is going to go from 0 to all the way up to the last index, which is the length minus 1. And then here, you can use string concatenation. So basically that just means adding to the string, and add an underscore to whatever guess used to be. So say our word is Python. Then the length of the string is 6. This for loop is going to run 6 times. And the guess starts out as an empty string. At the first iteration, you're going to add an underscore to an empty string. So your guess is now going to be 1 underscore. And you do that 6 times, you're going to end up with a string that is 6 underscores. And we just want to return this guess.
I have a question,
The-
Brink.
Yeah, go ahead.
In my code, so you did it as I in a range. Would it
Mhm.
also be okay to just do the character itself since we're not using it? We just want to iterate through all of them.
As in like for I in word.
Yeah.
Yeah, that'll be totally fine because you're not actually using I, right? You're just using the number of times you want to iterate. That'll change in the next for loop.
Okay.
Viren, you can also show them the like the shortcut with just the multiplying also.
Yeah, so there is a shortcut that we can do because this guess equals guess plus underscore. If you realize this can also be shortened to guess plus equals underscore. So Tim brought up a good shortcut that you can use is guess times equal underscore. Oh, sorry, guess equals underscore times length of word. So this is just going to repeat this however many times you need to.
Yeah,
This is just a shortcut. Don't worry about it if you don't get it right now. Just stick to the for loop because it's tried and tested as far as we know, and it'll get the job done as well. Just comment this out for now. The new guess function. So we have three parameters: the letter, the word, and the guess. We're going to be needing all of them, and we want to iterate through word and basically create a new guess and replace the old guess with the new character that's correctly guessed. So that's the difference. Here we're going to create a new empty string and then iterate through the word as well. Again, Chase, like you were mentioning before, you can also make this for I in word because you're not exactly using the index itself. You want the characters. But there's two cases here. The first case is where our letter, correctly guessed letter, matches the position in the word. So if word sub I equals letter, then we want to add that letter to new guess, because that means we've gotten the correct position of where that letter should be in the guess. So for example, if we have Python, we correctly guess H is in the word. It's going to match at the fourth position. It's not going to match at the first, second, or third. So we only want it to be appended to new guess in the case where these are the same. And the second case is where they're different. H with P, these are not the same. And we just want to add whatever was originally in our guess. So whichever letter, maybe it was an underscore, maybe we already guessed P correctly. Regardless, that character is going to get added to new guess and not the letter. And when we're done with this for loop, we just return new guess. Does anyone have any questions on this function? All right, we'll move on. Type it in the chat if you do later on, and definitely answer that. So the function that runs our game is going to be run game. We do a few things here. First is create a word to guess. This is going to be our secret word. Just to go through what this does, random.choice basically picks a word from this tuple randomly. It's a pretty useful function if you want to choose things from a list and without having to have a set hashing function or any way to randomize it. And then .upper just converts that string to uppercase. That way we won't have to deal with mismatches between lowercase characters and uppercase characters. My guess is going to be the guess that we're making. We're going to be setting it equal to the return value of get guess. So over here, we return a string with all underscores, and that's what we're going to set my guess equal to at the beginning. The parameter we're passing in is word to guess because this is our secret word. Lives lost is going to be initialized to 0 because at the beginning you have all of your lives. And this is going to be our empty array holding the list of guessed characters. Okay, so now we're gonna get into the loop. We're gonna keep running the hangman game until we've lost all of our lives. And the lives is actually equal to the length of this hangman tuple. Let me change this to the left arm. But these are just a bunch of body parts that you lose when you play hangman if you guess incorrectly. So we have 5 lives to start off with, and as we increase the number of incorrect guesses, we should be adding more and more limbs. So this is just a print statement. It'll tell the user how many lives they have left, and then it'll print the guess, so all the underscores separated by each other. And this will do this every time. So every time you guess correctly, incorrectly, on the next iteration, it's going to tell you how many lives you have left, and it's going to print the state of your guess, so how far you've gotten. And then it asks for input. So we covered input. You enter a letter and converts that letter to uppercase so that it matches with the word. And now we have to implement the 3 cases. So first of all, does anyone have any questions on the code that was already given to you? Because you didn't really have to interact with this part much. All right, then we'll move on to the cases.
Wait,
The first
I have a
case.
question.
Yeah, go ahead, Chase.
Why are you doing, what is dot upper?
Dot upper
on
converts the input to uppercase.
Oh, okay. So you're just making them all upper then?
We're making them all uppercase so that they match with each other, because lowercase characters and uppercase characters are treated as not equal to each other.
Okay.
So the first case you have to implement is if the letter has already been guessed. And this is actually pretty straightforward. Like we said, Python is very similar to English in the sense that we can literally type if letter in guessed. So this basically checks if the letter is in this array that we initialized. If that's true, we can just print something like letter has already been guessed. And then we can use the continue keyword to actually skip the rest of the while loop. Skips everything below it and just will go to the next iteration. If the letter is already guessed, we don't hold it against the user and we don't hold it as their benefit either. The next case is if the letter isn't in the word. So this is also pretty straightforward. If letter not in word to guess. What we need to do here is we need to print to the user letter is not in word. And then we also need to tell them which limb has been lost. So the easy way to do this is do something like hangman's, and then we access that tuple at a particular index. Has been lost. So how do we know which limb we want to use? Because we don't want to repeat limbs, right? We can't have him losing his head and then him losing his head again, or you drawing the head. That doesn't really make a lot of sense. So you kind of want to pass over each element. And the way you do that is actually by using an index, which we've given in the form of lives lost. So as you increase lives lost, you start losing a different limb. And so we can add that as our index. So on the first incorrect try, lives lost is 0, where we'll access the 0th element of hangman. That's the head. The head gets drawn. But we don't want to keep doing that again. So we need to increment lives lost. So that next time it's going to access the left arm, and then the following time it's going to access the right arm, and so forth. So for the last case, it's if the letter is in the secret word. So we know that if the letter is not in guessed, and if it's not in the word to guess, then it has to be in the word that we want. This is just going to be one line of code, very straightforward. My guess equals, and here we need to call the new guess function because we're updating our guess and returning the new guess value. So my guess equals new guess. And the parameters we're passing are letter, word, and guess. So here we have the letter, word to guess, and my guess. And that'll return an updated version of my guess with the new letter in all the right positions. So now once we finish with this, these blocks, we need to add the letter to the guessed array because it has been guessed and it won't be used again. So for that, we use the command guess.append letter. Now we need to fill in the condition to exit the function. This case is if it's correct. You correctly guessed the word, it was word to guess. So if the user has correctly guessed the word, that happens only when my guess is equal to word to guess. The moment those two are equal, they've correctly guessed it. And then we just return, we can just exit the function, we're done. We can also add a line here that prints game over, the correct word was, and then word to guess. Because what happens if the while loop ever gets exited, that means that they've lost all 5 lives and they've lost the game. So then we can print this. If they've correctly guessed, then the function will return and this line will never get printed ever. So that's why we can kind of manipulate the while loop and the return statements this way. So then run game, this will actually call the function. It'll execute, everything will work, hopefully. And we can try running this now. Anyway. And then real quick, we'll probably add this while loop because we have some time left. Okay, 5 lives. This is a 6-letter word. We can try, I'm guessing A. It seems to work. E. Hangman's head has been lost. Okay, that's really unfortunate. If I guess E again, the letter has already been guessed, which means that nothing happens. And this R. More lives are being lost. I'll just guess X to make us lose more lives to see if our losing lives part actually works. The correct word was Kosla. Okay, that's really sad. And so we can play this again. And this time I'll just cheat and look at the word so we can get it, see if it works. It's probably going to be IEEE. So I'll guess E and I. Congratulations, you've correctly guessed the word. It was IEEE. Awesome. So our run game is working pretty well. Does anyone have any questions about the if, elif, else block? All right. So the last thing we're going to do is create a while loop to ask for user input on whether to play again. So like you saw in the example slides, we can kind of just start this while loop with while true, which basically means this is always running, no matter what, until we break out of it. So the way we would break out of the while loop is if the user tells us that we want to stop playing. So we need to take some sort of user input. So I'm just going to create a new variable called play again that takes user input. And it'll ask the user, play again. And then it'll tell them either yes or no. If play again is equal to yes, then we just want to run game. And then it's going to go back to the start. It's going to ask them to play again. If it's yes, run game. If play again is equal to no, then we can break out of the while loop and the program ends. So does anyone have any questions about what this code does, what break means? All right, so let's go ahead and run this. 5 lives left. I think this is also IEEE again. Congratulations, you've correctly guessed the word. It was IEEE. Play again. Yes or no? I can enter yes, and then I'll get a new word. It inputs a new word because here we had random.choice. So it's going to select a random word every time. And let's try this. Lots of A's. I'm going to cheat, and it's asparagus. Great. G-U-S, asparagus. And here, if I play again, the program will end. So that's a complete hangman game. Does anyone have any questions about any part of the code? All right. You can always add more variations. If you want, you can even try drawing a literal hangman person every time. You can be more descriptive in terms of the types of limbs. You can change the indexes. There's a lot of room for experimentation, but this is just a good starting point if you want to just keep improving upon your programming skills. And I think I'll stop the screen share there.
All right, I'm gonna share my screen again.
All right. So on to the last part of this workshop is basically just where to go further from Python. So that was all the basics like data types and loops and all that. And it's the fundamentals of everything, but there's a ton of more complicated applications as well. The first thing that you'll probably want to do when you start programming Python is to choose where you want to program in. So integrated development environments, otherwise called IDEs or IDEs, however you want to pronounce it, are basically just a tool that makes programming easier for us. Because technically all this programming could be done in Notepad and you just type out all the words and get all the spacing right and make sure to add your .py suffix, and then it'll be a Python file and you can compile it. But it's not very nice. You'd just be typing, there's no like tools or anything. And IDE is just like an app, like we used Google Colab. It had a couple nice features, like whenever you did the if block and added a semicolon, the next space would automatically be indented and things like that. So these IDEs will have different functions to them that could help you. They might look nicer, but just to give you an idea of I personally use PyCharm myself. But it's not online. You can look up the bottom line is it's just something like oh, my mic does this sometimes. I don't know why. I hope I sound like a rock concert. Is it better? All right. I don't know why it does that. Sometimes it just breaks. But yeah, there's plenty of online resources to find an IDE you'd like. I personally use PyCharm. I don't know if it was Tim or Will in chat who was talking about VS Code. That's Visual Studio. But yeah, you can make your choice anywhere. It's just an extra tool to help you. And then as far as applications and advanced applications of Python go, so we did a basic program like Hangman, and we can do that with all like the built-in types and stuff. But Python, one of the best things about it is it's so widely used, and people have made extra add-ons to Python in the form of libraries that add extra functionality to the language. So in the case of you're trying to maybe work with web servers, there's a bunch of add-ons like Django, Pyramid, Flask, things like that that let you like basically run a web page or the back end or the front end or anything like that through the code of Python as opposed to other code used more commonly in online platforms. And then honestly, probably the biggest application of Python is in a bunch of scientific fields. So we have, I am assuming that's pronounced SciPy, Pandas, IPython, NumPy. They're just a bunch of libraries that add in an extra functionality. So like NumPy, you'll see a lot in like mathematical applications that has a lot of stuff to do with like graphs. So if you want to like visualize data, probably the biggest application of Python, honestly, is in machine learning. And I believe Pandas and TensorFlow are two libraries made for machine learning. And they give you just extra functionality so you don't have, they're all made in Python. So the base of the libraries is all made in the base language of Python. But the libraries just give you extra functionality so that you don't have to program it again to get the same functionality. So that's one of the best things about Python is its huge applicability because of so many different libraries. But yeah, that's it. So thanks for coming out to Programming in the Cloud. If you have any questions, I'll be sticking around at least until 5 if you have questions. You can also email us, so IEEE at ing.ucsd.edu, or the TSE folks at tse.ucsd.edu, or stick around in the chat or anything like that. But yeah, thanks for coming out. Hope you guys had a good time and learned some good stuff. Oh no, the chat's devolving into ACM now.
Oh no.
Here comes the memes.
Okay, I'm gonna stop the recording. If I stop it, it'll save, right?
It should. I think it saves it locally somewhere.